Graph Theory Class 12 Video 1. In this video we're going to talk about Hamiltonian graphs. So let's begin with the definition. First we're going to define what a Hamiltonian circuit is. So a Hamiltonian circuit is a circuit that visits every vertex exactly once. Okay, if you recall, a circuit is just a path, a walk, where you begin and end at the same spot. And a Hamiltonian circuit is a walk where you visit every vertex exactly once and you end back where you started. A Hamiltonian graph is just any graph with a Hamiltonian circuit. So it's very similar to Eulerian, right? The definitions are directly analogous to Eulerian. Eulerian, we have every edge exactly once, and Hamiltonian, we have every vertex exactly once. Okay? One thing I will point out is that Hamiltonian stuff is much harder. Okay? So the Hamiltonian side of this game is much harder, because if you recall, there's a theorem on the Eulerian side, and it just says that like a graph is Eulerian if and only if all vertices have even degrees. Okay? But on the Hamiltonian side, there's no easy theorem. There's a bunch of partial results which help you determine if a graph is Hamiltonian or not, but there's no theorem which completely sums it up like there is for the Eulerian side. Really, the fact that this theorem exists in the Eulerian side is like a very nice gift. Okay? Checking the degrees of the vertices and that being sufficient to completely determine if the graph is Eulerian, that's really quite wonderful. Okay? There's nothing as easy or as nice in the Hamiltonian side. And maybe just some background motivation. So why would you care about Hamiltonian graphs? Well, if you think about graphs as representing maybe the vertices are towns and the edges are roads, then a Hamiltonian circuit is like a trip where you visit every town exactly once. So this could be useful for like delivering mail or like trash pickup or something like this. Like you want to visit every town exactly once. Whereas the picture for the Eulerian is more like you want to drive down every road exactly once. That's just one interpretation of it. Okay? So let's do some examples. So example, are the following graphs Hamiltonian? Not every graph is Hamiltonian, and it's a reasonable question to ask, are the following graphs Hamiltonian? Well, the only way you can convince me a graph is Hamiltonian is if you give me a Hamiltonian circuit. I want you to actually tell me what the circuit is. Okay? And the easiest way of doing that, if it's not a multigraph, is to label the vertices like this, and then try and find a Hamiltonian circuit. So I could try and do something like this. Easy, right? Very easy. So if I translate that into the algebra, what that is A, B, C, D, E, A. This is a Hamiltonian circuit. So the graph is Hamiltonian. Okay? Like, I start at A, I travel to all the vertices, and then I end back at A. And obviously, this isn't the only Hamiltonian circuit. There's lots. Like, I could do something like that. That's also a perfectly valid Hamiltonian circuit. Okay? So this graph is definitely Hamiltonian, and in fact, it has many different Hamiltonian circuits. Well, let's move on to the second graph. Okay, this tree with 3 leaves. So this one, if you think about it, it's not Hamiltonian, because no matter where you start, okay, you need to visit other vertices and then return to back where you start. But that's impossible without going back through the center vertex, right? You can't possibly like visit other vertices and return without going through the center vertex multiple times. Okay, so that's like a hand-wavy heuristic argument, but I think it's because the graph is so simple, it's acceptable. Okay, so this one here is not Hamiltonian. It's impossible to find a circuit that hits every vertex exactly once. Okay. Oh, when I say you hit every vertex exactly once, you might object to, like, up in the first example, I say A twice. Yeah, okay. It's like almost a grammatical problem. You begin and end at the vertex, at the same vertex, so technically you hit the start vertex twice because you start and you finish there. But you know, don't try and pick a fight. Like, you know what I mean. You want to hit every vertex exactly once. So in general, it's very difficult to prove that a graph is or isn't Hamiltonian. In the future videos, we're going to talk about a theorem which helps you tell if a graph is not Hamiltonian. But that's the end of this video.